Hello and welcome to my first tutorial. In this tutorial I'll be covering how to implement Apex clothing into Unreal. I'm making this tutorial mainly because I'm currently developing a game and I myself had a lot of trouble to understand how Apex worked from the ground zero. And I had a really hard time understanding how the pipeline worked from having your model and making clothes with, physical properties. And well, I decided to just try and help other developers to have a better idea of how Apex clothing works, since it's such a cool feature of Unreal Engine and it seems to have a lot of missing documentation, or at least I had a real hard time finding it. Now, there's an NVIDIA tutorial. It's from 2012 or something like that. I'm gonna mention it maybe a couple of times during this tutorial. It's a good idea maybe for you to check it out as well. I think they have versions for Maya and 3D Max through their official Apex clothing website. I'm going to try and leave it on the description. And well, basically, it's a good idea to have those tutorials in mind as well, together with this one. I want to mention from the get-go that I'm not a professional of any kind. This is kind of an amateur tutorial. I'm going to apologize in advance because the materials I'm going to be using are not really the ones I'd like to show you how to work Apex with, but I think it'll be good enough for you to have an idea of how the system works. For the things that are wrong, for the materials that I'll be using, I'm going to tell you exactly what I think is wrong with them and what exactly you should do about it in your own models. So this tutorial will cover both the concepts of using a skeleton that has everything you need in it. And what I mean by this is you have two ways of dealing with clothing. The first one is you have a character that's fully clothed. Imagine something like God of War. Kratos doesn't really change outfits very often, and it's easier to have a couple of outfits that you change than have the clothing all programmed inside it. The other method is having something like, imagine Dark Souls or any sort of RPG that you can change clothing, and there's a lot of clothing sets. It's done slightly differently because in the first one, what you have is a model that, it doesn't have to worry itself about several pieces of clothing like bottoms and tops and, so several pieces of clothing. And you have models that have various, like for example in Dark Souls you have head, torso, legs and boots. Obviously they don't have clothing physics on all parts, but for example on the legs and on the torso, it's a good idea to have some physicality going on. So I'm going to try and cover both. I'm going to tell you right away, it's obviously easier to just have a model with a set of clothing that has all the Apex configurations all done, rather than having a model that has several clothing parts subdivided in it. So basically how this works is, well, let's kind of get started with the NVIDIA part. The reality is you can work with Maya, you can work with 3D Max, and you can work with the standalone NVIDIA program, which is this one. It's the Apex standalone SDK, which you can download free from their developer website. You can download the plugins for Maya and Max as well for free, just have to register as a developer. Bear in mind, a lot of the features overlap on plugins and this program, but some things might be different. So if you're wanting to use the plugins on Maya and Max, you might just have to adapt yourself for the features. I apologize. I think this tutorial is going to be a bit longer than it could be. I'm going to ramble a little bit, but hopefully the point of helping you guys will come across. So let's get a couple of things. The first one is if you want to make your character like, say, Kratos, which has, or like Nathan Drake, which has a set of clothing already in it, so it's not subdivided. I'm going to call it type 1 from now on. So in this type 1, if you have it, it might be a good idea to get it through Mixamo. If you're not familiar with what that is, Mixamo was a company that's been bought by Adobe last year or something like that, and it's incredibly helpful for developers. Not only at the moment does it have a lot of free animations that you can just export from there. I might just as well show you a little bit. Not only does it have that, but it also allows you to export models with the default Unreal Engine skeleton. That means you can only worry about making the mesh itself. You don't have to worry about rigging it because Mixamo does it for you. So if you get a model from somewhere else that has a different skeleton, you can upload it through Mixamo. And what it'll do is it'll make a rig for you. You can export it in various types, including Unity and Unreal Engine, and that's been incredibly helpful. It's been helpful for me and for this tutorial because I'm going to be using models from DAZ 3D. If you don't know what that is, it's a cool website that has all sorts of 3D modeling. So you get clothing, like you can see, well, maybe not this one, but you can maybe see here. It takes some getting used to because of how it works, but bear in mind a couple of things that I learned throughout trying to work with clothing. Basically, DAZ 3D is really cool, but it's not really appropriate for video game developing. Why? Well, because these models here are really good, and that basically means they have a lot of polygons. This model right here maybe has around 200,000. I've seen dresses that have close to that. And if you don't know about it, I'm gonna tell you right away, for video games that you'll be doing in Unreal, you don't want anywhere near that amount of polygons. You're looking maybe if you can make a cloth with 5,000, 7,000, that's really what you're aiming for. If your model is type 2 and it's subdivided into clothing pieces like bottoms and torso, you want to reduce that even further because you don't really want models with more than 15,000 polygons or something like that. I mean, if you're making your game specifically for PlayStation 4 or Xbox One, which have really powerful engines, maybe you can stretch these numbers a little bit. You'll have to test it yourself. But if you're making it for a computer, well, since you want a lot of people to maybe, be able to play your game, if you're not purposefully making a game that's, really high end, then you don't really want models that exceed 10,000, 15,000, and maybe even that is a bit too much. So this is the problem with that. It has too many polygons, because other than that, these models are great, the clothing are great, the artists here are really good. You can buy, and you kind of have to buy, the indie license if you're an indie developer, which costs, I think, around $500. So you can use that in-game. Another thing you probably have to buy is the Decimator, which you can buy on this store, which costs around $100. It may be a good idea for you if you're going to go through this whole process to buy the Platinum Club thing on DAZ 3D, but I'm going a bit maybe further. Just letting you know that the model I'm going to be using on this tutorial comes from here, and that's why I'm not really happy with the model I'm going to be using, because it's from here. It's been decimated, which means I've reduced the polygons quite a lot from their original count. But the problem is, if you decimate something that has 100,000 polygons to say 10,000, it's not going to look great. There's going to be holes in it because the decimator is a good tool, but it's not perfect, so it's not going to be really what we want to use for video game developing. Nevertheless, if you want to do it, and like I say, if you're going for a high-end type of video game, maybe you can use these, because as long as they're from DAZ Studio and you buy the indie license, you're good to go. You just have to decimate them as you find them appropriate. So, with that in mind, get these models, get your clothing, go through Mixamo, re-rig the character so you have an Unreal skeleton. And by the way, with an Unreal skeleton, you can use the animations on the marketplace, or any animations that have that kind of rigging, and then you'll end up with a model. That model, my recommendation is that you import it to Unreal and then export it from Unreal again, and use that exported model as your model that you're going to be using for clothing. This is because when you put a model, for example, like from DAZ on the Unreal engine, what happens is the engine slightly modifies it. See, if I import it directly from Mixamo, from the model that comes out of Mixamo to here, this list right here wouldn't be like this. It would have a lot more materials. And by the way, this is too many materials. I just haven't reconfigured this model to be more appropriately, shall we say, materialized. This has too many. But even then, if you, like I say, if you put it here directly from DAZ, it'll have even more. This means that Unreal Engine kind of adapts the model that you import into it to itself. So if you export that one, you're guaranteed to have the final version that Unreal wants you to have. And then, delete the one you've put in the first place and re-import the exported version and use that as your model for the Apex program. So once you load your mesh, this is kind of the menu you're gonna have. This has all the materials selected. We don't really want that. One of the things you want to do is, you want to select the material that's going to be your main clothing material. In this case, it's the coat fabric material. This is the material that we want to have configured for physicality. First thing you want to do is generate the tangent space. This helps Unreal. I can't really explain why, but it does. You do that. Further ahead, you have your model. Sometimes the model is going to be lying down. You may have to activate this Z-axis up thing, and then it works like this. So, how does this work? The first thing you want to do, and this is really important, and this is something you won't see on FLAC tutorials, which there are a bunch of in YouTube, a lot of FLAC tutorials. We're not looking at a flag, we're looking at a human. So the first thing you really want to take care of is your collision volumes. This here is what's going to tell your clothing that it collides with something. Because if you don't have a collision volume, what's going to happen is your clothing is just not going to collide with anything. It's going to go through your character. And you don't really want that. So this model isn't optimal. It shows you all the submeshes without any sort of parentheses like you have over here. So it doesn't really help your workflow. But what we want here is we want maybe the torso. So we want the torso, which is right here. and we want the legs as well. So the legs should be maybe right around here. Yep, there we go. So you want to have your clothing selected. This is not your clothing, your bones. This is what's going to allow us to configure the collision on your mesh for the clothing. Now, a couple of things. This model right here is completely naked except for the coat. This is because I want to use the coat as a completely separate cloth in the video game, which means I'm not going to be using the man. I'm going to hide it. Ideally, you don't even have this mesh here. You can hide it in Unreal using a transparent material, or in some other way I imagine exists. But in reality, you would want to use the coat alone, but you would want it to have a skeleton. So even if you only use the coat, which is optimal in terms of performance and, you know, having less load on the engine, you still want the skeleton inside it. That's really important for you to have collision. The second thing is, I'm sure, as I've seen in other tutorials, that Maya and 3D Max do this better than the standalone. As you can see here, this has generated collision, but this has capsules around areas of the body. Whilst in Maya and 3D Max, you might find that it detects the edges of this mesh, and it allows for better collision. Now the thing is, if you don't have a mesh in those plugins, it means it won't do the detection really well. Whereas in this NVIDIA SDK, you know, it doesn't matter because this mesh isn't really used for edge detection. It's just a skeleton. So you get your menu here, like this, the collision volume generation. You pick the parts that you want, and the first thing you do is, well, let's find the head. Let's find the head and, well, as well the arms. We don't want these armpits here because they're not really going to be used for clothing collision. So I'm going to tell you right away that this program from NVIDIA, it does work for what we want, but it's not been updated for a while because it still has some strange features like, well, you can't really add capsules as you want. I mean, you have to generate them and adapt the ones that it generates because the program doesn't really add collision boxes for bones that doesn't have, like, you can't select the hand and add capsules. It won't really work very well. I mean, try it for yourself if you want, but it won't really work really well from my experience. We don't want spine 3 either, and, you know, just remove bones as appropriate. As well, in the feet, we don't really need collision. It won't be colliding with the feet. There we go. Okay, so these are the ones we want it to be colliding with. Now bear in mind, you will have to configure this appropriately for your model. This, the NVIDIA program, like I say, isn't really great at generating collision, but it's kind of okay because you can just pick these capsules one by one and kind of, you know, you can increase the radius here of these capsules. You can rotate them like so. It's not great workflow, but it works. I mean, you'll get there eventually. You'll get these collision volumes up, and this part, you know, I'm not going to be configuring this very precisely. I'm just going to leave it as is, but you can do this yourself with more precision, so your clothing works better. So this is really important that you get your collision volumes generated. So the next part is this this feature called channel selection, which is where you'll paint your your cloth to have physicality calculated. Now the way this works is you want to put some maximum paint on your edges. I mean, this will vary a lot depending on what type of clothing you have, and this depends as well on what kind of preference you have on physicality, but this is the gist of it, and you'll have to adapt yourself to the things that you want. I've started with 0.1 and then I've gone to 0.7 because the way this works is you want your edges to have more painting than your inner parts, so that your edges kind of behave more freely and less strict than your inner parts, much like kind of real clothing works. So I've gone to 10, to 7, to 4, and to 1. After you've painted this, you can smooth, so it'll make a nice, neat transition between 1 and 10. It'll be better this way. Now, there's a thing that unfortunately I cannot show you in this tutorial because this coat isn't optimal for our use, but I'm going to show you how it works if you have a good model. And what that is the L2N latch. Pardon me. How this works is this particular coat, it has a really thin layer. What this means is that these vertices right here, they're the same as the ones behind, which is why I've painted right here. Well, for one, my paint is volumetric, as you can see here. You can make it flat, so it paints only the surface of what you're painting. In this particular case, it doesn't matter because the verts are the same. This vert right here is the same as this one. And this, again, this is not what you want. What you want is a bit of thickness. What you want is to have at least a bit of like 2 layers going on, and an in layer and an out layer. And this will help you make the clothing look more realistic. And for example, a coat usually is thicker than this. But then again, if you're using a really thin shirt, you might as well just have it like this is now. But the thing is, for L2N latch to nearest, this coat won't work as we want it to. This part right here is the one that in the NVIDIA tutorials you'll get a better idea of how this works. Because what this is doing is, if I paint right here, this will paint on the other side as well. But if you're using a good model that has thickness, this will only paint the inside and not the outside. You can also, it really helps if you do a culling. So if you use here the culling on counterclockwise or clockwise, I can't really tell right now, but if you see here, this should only allow me to paint, or at least to better see the outside and not the inside. And in counterclockwise, it should be the opposite. This will help you paint thick models better. In this case, again, it won't really do justice because, you know, it has nothing to latch on. What this feature does, I'm going to try and explain it better, is what this feature does is it'll attach your inside verts right here to your outside ones. And this will mean that you can then deactivate the verts on the outside and only have your inside working. And what this will do is it'll stop, for one, it'll stop the outside verts from being calculated because they're attached to the inside. Only the inside verts will be calculated whilst the outside ones won't. So this will help performance from the get-go, and it's just better to have less verts being calculated as a general rule. And it'll also make your clothing physicality work better because then those verts won't collide with other parts of your body because they're not even being calculated as physicality. Only the ones on the inside will be calculated. So these ones won't even be able to go through the collision. At least they shouldn't be. Again, the NVIDIA tutorials explain this part better because they have an appropriate 3D model for this. So the next part is, again, once you have your notch tenuers painted, and you can delete this one because you won't need it anymore. But once you've got this done, then you've got here the formable parameters. You want to add a little bit of thickness so that the coat, seems to be thicker. As you can see, this kind of simulates how thick the coat is. I've exaggerated a little bit on mine because the model is thin. So you won't, you'll have to play around with these values to see, how it works for you. The next thing is clothing materials. So there's a lot of parameters here. I mean, you'll have to, I'll explain a couple of them, but the others you'll have to play around and see how they adjust for your models. I can tell you that length stretchiness basically means what it says. It'll stretch from the get-go. If you move this slider, it'll stretch this model right here. If you put it a little amount, it'll just stretch a little bit. If you put a large amount, it'll stretch right down to the ground. Depends on the type of clothing that you'll be using, and again, it's just something you're gonna have to try yourself. Bendiness is obvious. It regulates how much the cloth can bend. I've found that some of these parameters just don't do a lot, and some of them cost quite a lot of performance. Your damping is also kind of self-explanatory. I mean, it'll make the clothing a bit more rigid if you increase this value. Again, with the stiffness, friction is something that I have not really been able to understand what it does, but I can tell you that it costs performance, so I usually just put it down to 0. Solver frequency is kind of important. It's the amount of times that the physical solver works. So if your clothing is simple and you're not really worried much about the collision on that clothing, like say for example a scarf or something like that you're not really worried about how much it collides with the model, you can turn this down because it will increase your performance in general. And the opposite applies. If you have a really complex clothing, you want to maybe increase the solver frequency because it just increases how many calculations are being done, and it will increase the overall physical quality of your cloth. Gravity multiplier also speaks for itself. You can make this lower or higher. Obviously, a lower gravity will mean that the clothes float a lot more and take a longer time getting back to their original position, whilst heavier gravity will make clothing also more rigid. It means that they won't really go up as much, like this coat will go up when he goes. The other parameter of interest is self-collision thickness. Now, this parameter right here is also performance costly, but it's kind of necessary to not be at 0 if you have clothing that is complex, such as this coat. It'll make the collision of itself, like the vertices colliding with one another, better. So this value right here, self-collision thickness, will help your vertices not collide with each other and reduce the bugs on your physicality. Because one thing you'll notice is that clothing is never perfect. Even on AAA games like Dark Souls and Bloodborne, you'll see that the clothes still collide badly sometimes with certain parts of the body. They still go in, and it's kind of okay. The industry of video games has kind of accepted that whilst clothing physicality is cool, it doesn't have to be perfect. And as players, we don't really notice, or we don't really care if there's a bit of collision or lack thereof going on. But you want to have your self-collision thickness a bit high for something like a coat like this one. So another thing I wanted to mention is right now I'm only using the fabric, the coat fabric as a material, but say I wanted to use like the sleeves. This will mean that when I export my Apex file and import it to Unreal, there's going to be two variables, and as you can see in Unreal, well, I'll show you in a bit, but as you can see in Unreal, you have to import your Apex file, and then you have to select on the materials, you'll have to select on the materials which kind of Apex variable is attached to it. I guess it's just better for me to try to show you this. Okay, let's just import the one I'm using. I'm gonna pick the skeleton, just give it a little bit. It's gonna construct some of the shaders, might take a little while. But what we want is, as you can see, there's a lot of materials here. Once you add your Apex clothing file, just give me 1 second. Once you add your Apex file, you'll see that there's an asset here. In this case, it's called Regency Code. And if you've picked two materials, there's going to be two elements here. It's okay. Once you go on clothing, there's going to be two here. Just pick the one that's appropriate. It may not be clear on the names here, just like here. It might not be clear which one is which, but just don't be scared. Just, try it out and see which one belongs to which. There's not really a problem there. But just getting back to this, because this has just been done in front of you. If you do your start simulation, you'll see there's 2,000 verts being calculated. This is a bit much. You want it to be less than this. But if your frames per second here are okay, assuming you don't have a really good computer that is able to calculate this stuff easily, if you have 60 frames per second, it means the performance is not too bad. But again, you really want this to be less than this, maybe 1,000, maybe even less. The lesser vertices you have with a good working model, the better, the more performance you're going to have. As you can see here, the code's working fine. Obviously, this is not really well done. There's a collision capsule here that's going outside of the leg. Again, this is something that you just have to configure to make it work better. But it's working fine. You can test it out here. That it works fine. It's painted up to this part over here. You can go further up if you want. You can even make almost the entire coat with physicality. Just bear in mind, you can't paint everything because this has to hang on to something. In this case, all these vertices are hanging on to the rest of the coat. And if you paint up to here, you still have to leave parts unpainted. Otherwise, the coat's just not going to work. It has to have something to hold on to. But anyway, this is how it's done over here. After you've simulated, you can alter your parameters to see if it works better. Just like you can, I can show you that if you reduce the gravity, and by the way, you always have to start simulation again once you change a parameter, otherwise you won't see the difference. As you can see, I've lowered the gravity, and this has, gone all floaty. You don't really want this like this. But anyway, after you're all good and done here, save your asset. It's going to ask you to save it as an APX file, which is what you want. save it wherever you want, import the model to Unreal like I've done here, and come over here to the clothing part, import your Apex clothing file through here. We can go on to the code fabric, which is what we've worked on, then you can apply it. By the way, there's also a bit of a problem with the material UVs on Apex. I'm not entirely sure how this works on the plugins, if this happens or not, or if I'm doing something wrong, which is entirely possible. But as you can see, this material right here, which belongs to the whole coat and is, subdivided into the pieces of the coat, isn't working well once you add clothing. This black part is not really adapting well. This is something that I personally don't know how to fix, but if your whole coat is using an entire material, maybe this works better. What I can show you is if you just create a material, like something like a coat material, and come over here, just paint it like, I don't know, just a nice light blue, put it on your base color. If you come over here, coat material, it'll now become blue, and you can kind of get rid of that UV problem that you had before. Again, I don't think this is the best practice, but at the same time, it's what I've got to work with. Coming over here to show clothing and applying wind will let you know that the clothing is working, because as you can see, this is floating with the wind. So this is kind of the gist of it in terms of creating clothes and putting in an Unreal. This is the basics of it. But the other thing you can do, which is what I am doing, is if you come over here, you can select your Regency coat. You'll see, this skeleton isn't really very well configured. I wasn't expecting that, but it's a little bit weird. But if you come over here, in this particular instance, what you would do if you wanted to do type 2, which is that model with the various pieces of clothing, is you want to have your main mesh as your body. You might do it naked, have underwear or a shirt or something. You would want your mesh to be just the naked model. And then what you do is you add another skeletal mesh, you make it a child of that original mesh. You can put your coat here on your secondary mesh, right here. You can put your coat here, so something along the lines of this. Obviously this isn't going to work very well, but it's just so you can have an idea of how this works. You could do this, maybe this one, yeah. You could do this, and then if you hide or you don't even have this human model, then you'll only see the coat here. You'll only see the coat on this secondary mesh, and you can subdivide this into more meshes. You can have your top mesh, you can have your bottom mesh, you can have your coat mesh, however many meshes you want. Just bear in mind the performance. And the important part to have in mind here is that they have to be rigged the exact same skeleton as your mesh. They have to have the same anim class. Well, at least they should, so they're doing the exact same animations. Bear in mind what's going to happen is these skeletal meshes are going to be doing the exact same animation from the exact same anim class blueprint, so that the clothing is simulated, but it still has to get your animation from somewhere. The only thing that you want to bear in mind when you do this, obviously if you have type 1 models and you only want one mesh with your clothing done, you don't need to worry about this part that I'm talking about. You don't have to add this mesh. You just have to worry about the one you already have, and that's that. But if you want to subdivide it, you have to create more skeletal meshes, and you have to do this thing, which is bind cloth to master pose. I don't think that's it, actually. Just give me 1 second. It's set master pose component. So just give me a second. I think the way this works, I'm sorry, I don't really remember which one it is. I think it's like this. It's not that hard to test, actually, now that I'm saying it. Just have this being activated maybe on your begin play or something. Let's just see if that works okay. It kind of does. I think that's the order. You want your main mesh, your inherited mesh, as your target, and you want your following meshes, say you had more, you want to add them here. Or hold on, this is slightly embarrassing. Oh yeah, okay, I'm sorry. Yeah, this main mesh goes to your master bone component, and your other meshes, your coat mesh, your bottom mesh, whatever, they go on to target. And what this is doing, and this is very important, is it forces the synchronization between the following meshes and your main mesh. If you don't do a master pose component, what will happen is that basically your skeletal meshes won't be in sync. This coat mesh will be having this pose as well, but it's not synchronized with the rest of your meshes. So this is really important. Just keep this in mind. You have to do this for your main mesh and put the other meshes as your target so they're all synchronized. And I think that is the main, the gist of it. As you can see, you play. I don't know what's going on over there. What is going on over here? Why aren't you working? Hold on.